But so we often say that Peter is actually the inventor of moonbounce, but that's of course not actually completely entirely true. But he could have invented it. Anyway, Peter, you have been and still are very, very active on moonbounce. I meet you very often on random and everything. And over the years, you have become very active on more and more and more bands. It's impressive, really. And Peter is also the founder of the activity weekends. And that boosts activity on the microwave bands very, very much. Yes. Yes, on the millimeters. Therefore, it's logical that Peter is going to give us an overview of the 6 centimeter moonbounce activity that has been growing rapidly over the past few years. The word is to you.
Thank you. Okay, well, good morning everybody. Very nice to be with everybody again. Haven't really seen some of you since our Cambridge day. I think I'll try and do this from the screen here. Anyway, we'll see how we go. Right. So I think is that right? Yeah. So I think there is a little bit of a challenge here. You've just seen your EME experimenting on 23 sems in the early days, and it was a tremendous amount of fun. And we did collect numbers, but you know, I see people now really they're interested in getting a new grid on 23 sems, and I think there's something more to it than that. So I'm going to just throw down some challenges, I hope, or tell you what's going on up in the higher regions. So let's first of all see if this works. Yeah. So a little bit of history. So 6 sems started back in 1987. The Texas Club, the Texas Club, W5TMI. You can read the course. 1990s. It started to take off with those call signs. There's some other people that were there as well, but they were the core people who had sort of permanent installations in those days. And then in the 2000s, there were several things happened. As Dick said, we reinvented activity weekends. It was SL weekend when everybody gets on one band, and SSPAs came along, and people started people in recent years across them now started to go portable to rare countries and so on, with small dishes and the digital modes, which has pushed it along. And I thought these two curves are quite interesting. The bottom one is the Dubus activity, and then there's Vlada and his team's initials on 6 sems up above 100. I'm about 83, I think, something like that, and started in 2009. So yep, that's working. So we want to move up from 23 sems. So 13 sems, great band, but things are very spread in terms of allocation. 9 centimeters, another really good band for EME. I can debate that with you over a coffee. 6 sems, widely allocated with a common frequency, which makes it very attractive. Good results with fairly small dishes. It's a good engineering challenge, and that's what I think that was what was attracting Jan and I in those days. And you saw a lot of it in those pictures he showed of the dish and the equipment. The components and designs are around. You can find a lot on the web, and what I call pay, plug and play. You can buy most of the kit if you want to go that way. So what happens when you move from 23 to 6 sems? Well, it's worth reminding everybody that the higher the frequency, the stronger the moon echo. So why is that? Well, if you write the radar equation with a fixed antenna area and the same power and the same system temperature, then the signal increases as frequency squared. So we get 13 dB in going from 23 sems to 6 centimeters. And the losses and the increased noise from a few things tend to cut into that gain, but it's still there. And It's interesting. When I worked the last expedition, that the EA6 HP9 COG, the best signals were actually on 6 centimeters, and that was really interesting. Anyway, so small antennas work well at 6 centimeters. That's the one I was just speaking about there on the left-hand side, and that's Hannes's very nice 2.3 meter dish. Just to mention, I've done, this is about the third talk I've done on 6 centimeters with slightly different content and so on. But there's quite a lot of references in the other one and pictures of other people's kit and descriptions of them. And you can find those, I think they're referenced in the paper, but if not, you can find them on Google. But there's quite a bit now around on people's systems. So what's different from 23 centimeters? Well, the signal characteristics are different. The antenna pointing is a little bit more of a challenge. If you're moving up with a mesh dish, you need to pay some attention to the mesh. Most people mount their systems at the focus. I mean, that happens at 23 cents as well now, but certainly for the microwave bands, that's where you need to have it. And we're having to deal with interference from Wi-Fi, which Jan mentioned radar. Occasionally we get that, but it's not very common on 23. So just talking now about the signal characteristics, the Doppler shift is 5 times higher, and it's worth. Let me see if the pointer works. My pointer, remind me the top. I'm not pressing hard enough. Oh, I see the button. Yeah. Sorry, didn't see the button. Yeah, okay. So you see this minimum here. Vibration minimum, where the Doppler shift goes through the change of Doppler shift goes through 0, and of course on these bands it produces almost a pure T9 signal. Let's move on. Right, the next thing to talk about is vibrations, the variation. Jan showed a picture of the fluctuation of the signal. This is a very interesting opportunity I got when PI9CAM was on briefly on 6 centimeters. And if you look at their echoes and my echoes, their echoes are much narrower. That's because their dish is only illuminating the central part of the moon, and so the movement of the moon backwards and forwards, which causes a spread, well, it's still there, but the effect on the signal is less. And so you can see there the width on my echoes and the narrowness of the PI9CAM ones. Now I need to point to this. Can you do this? Yeah. Click on the. No. Go back. Yeah. My fingers are so wobbly these days. I can't do that. Oh, brilliant. Okay. Lovely. So this is. So this is actually received on Brian's dish, but that's sort of typical vibration on 6 centimeters. But you also get times when it is absolutely T9. So now talk about the antenna. You want to be able to point within the 1 dB beam width. There's no use talking about 3 dB beam widths. You're losing 6 dB on echoes there, or 6 dB to someone with the same dish. So if you look at the curves here, 3 meter dish, you want to be pointing to within half a degree. The moon is half a degree, so you're just effectively matching that. If your system is, if you're thinking, oh well, yeah, I can steer to 3 dB beam width, well, you're losing a lot of power. So you've got to pay more attention to that, and that throws back pressure on the dish mount and things like backlash in the gears. Again, if you look in the other the references in the other papers, you'll see some direction to people who've made very good systems. DL1YMK, also SA6BUN, has made a very good mount. So mesh size. I mentioned mesh size. I mean, you think of the mesh, with a series of holes next to each other. So the energy is diffracting around the edge of the hole. The thicker the mesh, the less the diffraction. But of course, the heavier the mesh is on the dish. If you double the thickness of the mesh, you're 4 times the weight. So there's some numbers here, what a very common one is 6 by 6 by 1 millimeter. That adds 18 degrees K, 18 Kelvin, sorry, to your system. A typical system temperature with a solid dish will be 85 to 95 K. So you're putting 20% on the system temperature, even with a 6 by 6 millimeter mesh. Now you can get around this. You can stick some aluminium foil over the centre, 50% of the dish, or 30% of the dish, and that will recover most of that, and that does work. Just do it with a decent overlap. So that, anyway, I won't dwell on the numbers, but if a 10 by 10 millimeter mesh, you're losing half the power. Hopeless. Okay, mounting systems at the focus. Well, power's expensive, and you've got to minimize the feeder loss by mounting the dish up there, or use waveguide. There are 2 or 3 people with waveguide runs up to the focus, which is quite interesting. Mike, yes, so there he is. Mike's the guy to talk to if you want some info on how to do that. There's a good picture of his arrangement in the paper. Minimize the blockage. I see some people with great big structures in the front of a fairly small dish at this frequency, and that is actually scattering in a lot of ground noise. It's not the blockage. The actual physical blockage is one thing, but there's a much less appreciated effect, and that is the fact that is creating side lobes that will pull in noise. Make sure you can adjust the feed position, because it won't be exactly where you have calculated it. Rigorous screening of all the units. I've had problems with noise from the units lower down the chain, going to the dish and then back into the feed horn. And so when you adjust it for sun noise, you're not just adjusting for sun noise, you're adjusting for the noise that you're getting from your own system. So it really is important to make sure everything is well screened. Weather protection, I mean, polythene bags are the simple way. There's some very good alternatives to that with, I think Brian uses half a waste bin as a cover on his system, which is very effective. So when you're doing it, put in a multi-way cable and put in some weatherproof sockets and 1 or 2 spare coaxes, because I guarantee if you get going on 6, you want to do 9, and you want to do 13, and you want to do 3 if your dish will go up to it. And it's better to engineer for that, when you at this stage. I just want to say a little bit about interference from Wi-Fi and so on. When we started building receivers for EME, there was pretty much nothing else there, and so we can have lots of gain. And now, of course, the situation is quite different. There's Wi-Fi. There's all sorts of things adjacent and coexisting with us in those bands. So, and I did some sums quite recently. And you take a typical transverter, and then you stick in front of it a 20 dB LNA. That LNA is about 1.5 gig wide. So you just do the KTB numbers, and and then stick 40 dB of gain on top of that. And then look at the last device before the mixer. The example I found, it was 20 dB, it was only 20 dB below its 1 dB compression point. That's with noise. Now comes along some Wi-Fi on top of that through your side lobes, and you're way into compression. Now, I know you won't mind me saying this, but VK3NX recently rebuilt his system on 9 and pretty much eliminated the interference he was getting from the adjacent systems that they've set up on 9 in Australia, just by chucking away gain and putting in a filter immediately after the LNA. So we have to start putting in filtering on these bands much earlier on than we did perhaps 10 years ago. That's just a filter that I made from something I picked up at a flea market. And the picture of the dish with the side lobes is to remind us that at these frequencies, it's just as easy to make things out of circular, where you've got a much better illumination of the dish and a really good profile and a good feed, and you can keep those far out side lobes down. Those far out side lobes there at the bottom, that is I think it's a 36 dB antenna, and they're only about 5 dB below isotropic. Those side lobes there. So anything around you're receiving at still quite a substantial level. Let's move on. So how am I for time, by the way? I'm not looking. Oh, lovely. Oh gosh, okay. I've probably been going a bit too fast. Right. Okay. Well, as I said, in the other publications and talks I've done, there's quite a lot of information on European systems, and I thought it'd be nice to look in this paper and in the written paper and here at some of the 6 centimeter systems in North America, and the activity there is slowly building up. You can see them here, and V6 BGT is the latest one. He's building for 6 centimeters as well. So just having a look now at V6TA's outfit, Grant's outfit, and so just to remind myself of some of the numbers. He has 37 watts, which he gets from combining two PAs, two stealth PAs here, and you can see the combiners there and there on the output, the input and the output going into the feed horn. Feed horn is a W2IMU dual mode horn with a septum. You can scale the design that N2UO described some conferences ago. I did a little paper on that for the UK microwave publication Scatterpoint. And it was a very easy job just to scale the dimensions. In fact, it's being used at the moment by Howard. G4CCH has got that particular antenna, and so okay, here we go. So here's the receive feed point, and here's a very important point for 6 centimeters. You need to go absolutely directly into the relay. Ideally, if you can engineer it so that the relay and the connector on the feed are male and female, or just with one adapter, that's the ideal. And then coming out into the LNA, which is just you can see it just behind there. It's noted on the screen. Isolation relay LNA, very, very short connections here, because the losses here really start to eat into the noise figure very quickly. So this arrangement says he's got 37 watts, it's a 0.7 dB DB6NT preamplifier, 432 MHz. He's got a pipe cap filter which you can't see. It's just below where those red wires are at the top right-hand corner, pipe cap filter to reduce the Wi-Fi or eliminate the Wi-Fi interference on that. And there's 3 legs on the feed assembly, 2 here and 1 at the back, so that he can move it to make sure it's pointing at the centre of the dish and move it backwards and forwards. You can't see the backwards and forwards bit too easily in this. But that's a homebrew dish, 5 meters, 0.45 FTD, and he's using pretty fine mesh on that, so not adding very much to the noise temperature with that 3 by 3 by 0.7. So the next one to look at is John's WA9FWD, 3.7 meter TVRO dish, 0.375 FTD, and again you can see everything's mounted at the centre of the dish. Again very short connection to the LNA, to the isolation relay, and then into the LNA. It's a V4MA type feed, Kumar type feed, and then he comes out of the LNA, and then he's got this filter here, with a multi-section filter that he picked up somewhere and checked it, and it had pretty good, pretty narrow bandwidth around 5760, and that has helped him get rid of his Wi-Fi interference, because John's in quite a built-up area, and he's got a couple of isolators there on the input and output of the filter. I'm just trying to remember how much power he runs. I think it's about 50 watts. I think he runs about 80 watts. He runs 80 watts. He's got a 100 watt amplifier, but he underruns it a bit. So those, right? Okay. So one of the things about 6 centimeters is that you can still build your own stuff. There's plenty of designs for feeds out there, transverters, PA, low noise amplifier. I've just got 1 or 2 examples in here. You're going to give me some prompts on timing, so I'll leave some for, okay, because I'm not looking at the clock. I can just about operate both of these things, but looking at my... Anyway, so there's two examples of feeds here. Ingolf and Hannes, who is, is that you over there, Hannes? No, I'm looking, there's Hannes. There he is, he's over there, yeah. So Hannes has done some wonderful machining on these feeds that Ingolf has designed, and has enabled the predictions to be very nicely confirmed. So, in my opinion, these are the very best feeds that are around at the moment for the range of FTDs that are covered, which is probably, if we say like 0.33 to 0.5, that sort of region. They work extremely well. All of my bands now have, apart from 70 of course, have these feeds on. They've got very good cross-polar performance, which means that your cross-polar side lobes are low, which people sometimes forget about. And on 23 centimeters recently, I had a QSO with Jack with his 67 Yagi and 120 watts, an easy an easy CW QSO. As I think my system temperature on 23, I notice the deviation from the torque is about 45K, so it's I don't think I can get it much below that, and a proportion of that is from the feed. On the right-hand side is the design for another very popular feed at 6 centimeters by Tommy, WD5AGO. A lot of people are using these feeds as well, Chaparral. So the dimensions are there on the internet. You're dealing with bits of pipe that are not that difficult to find. You can do this. You can make these without a lathe. they're better if you've got some access to them, perhaps for one or two of the bits. But there's no reason why you can't make these out of sheet metal. Right. So transverters. Obviously, you can buy transverters. This is just one design I found on the internet by Paul. I think Paul will supply boards for this. Or Paul, are you there? Yeah. There he is. Right. Okay. So Paul's here. You need of course a glass edge chain and an IF. For this, so you could use 144 or 432 as the IF. There's pipe cap filtering through the various stages you can see here and here. So to some extent you eliminate that problem I was talking about earlier of the high level of noise from the preamplifier overloading the final stage before the mixer.
5 minutes.
Thank you. Brilliant. Okay. Good. Right. This is the next thing, the PA, 100-watt PA design that Hannes came up with. It's been reproduced by at least three people. This is J4 BLC's design. It seems to be very reproducible. B6BGT has made one, WA6PY. And obviously you can use bits of it to. I run 40 watts certainly on my 6-meter dish. 40 watts, 80 watts is plenty on these bands. LNA. I only know of one LNA design. I can only find one LNA design on the web, and that's this one that WB5LUA came up with, which I use. 0.65 of a dB. Artwork is there. And again, pretty easy to put together. Well, I think that's it. So, thanks for listening. Be inspired. Get on microwaves. I've had a lot of help from a lot of people in putting these papers together with photographs. There's more photographs in the paper. So, I think now a few minutes for any questions. Is that right?
Yes, that's right. So, if there are any questions, just tell me. I will walk over with the microphone to you. Oh, no questions. That seems a clear story.
Everybody is eager to go to the coffee.
Yes.
Thanks everybody.
Peter, don't walk away yet. Don't walk away yet. Thank you very much. I think you're trying to tell us that we should be more active on 6 centimeters. Is that the message? I got it. Here's a little booklet for you to discover our beautiful country. Maybe you find some things that you didn't know yet, because you know so much. Thank you.
Thank you.